Hello everyone, this is the Q&A session 6 from the playlist of Heat and Thermodynamics. The topic is volume expansion, and today I have taken one question which was asked in the IIT-JEE examination in the year 2011. And this question is based on what we have studied in the session number 5. So in the session number 5 we have studied about the thermal expansion, and during that session we have learned that delta L upon L is equal to alpha L multiplied by delta T, where alpha L is a coefficient of linear expansion, delta T is the change in the temperature, delta L is the change in the length, and L is the original length. Similarly, delta A upon A was equal to 2 times of the coefficient of linear expansion multiplied by delta T, where A is the change in the area, A is the original area, and alpha L is the coefficient of linear expansion, and delta T is the change in the temperature. Similarly, delta V upon V is equal to 3 times alpha L multiplied by delta T, where delta T is the change in the temperature, alpha L is the coefficient of linear expansion, delta V is the change in the volume, and V is the original volume. So here in this question, we will be using this formula, that is delta V upon V is equal to 3 times the coefficient of linear expansion multiplied by delta T. So this question is very easy, and we have to now simply put the values of this alpha, that is the coefficient of linear expansion, delta T is equal to 100 degrees centigrade, and we have to simply now calculate the value of this V in order to find the change in the volume. So the change in the volume will be equal to 3 times multiplied by this coefficient of linear expansion, which is equal to 23 into 10 to the power minus 6. Delta T is equal to 100 multiplied by the volume of this aluminum sphere. So now here the volume, this delta V will be equal to 3 into 10 to into 23 into 10 to the power minus 6 into 100, and the volume of the aluminum sphere will be equal to 4 by 3 into pi r cube. Now r here, the diameter of this aluminum sphere is 20 centimeters, so r will be equal to 10 centimeter. So here I will be putting the value of r as 10, and so this is the final equation, that is delta V will be equal to, now from here this 3 and 3 will get cancelled out. Now I will be getting 23 into 4 pi, and here this is 10 to the power 3, this is 10 to the power 2, so this is equal to 10 to the power 5, and this is 10 to the power minus 6, so I will be getting 10 to the power minus 1. So from here delta V will be equal to 92 pi divided by 10. Now if I calculate this value, so I will take the value of pi as 3.14, so 3.14 into 92, this is equal to 288.88. So 288.88 divided by 10, and so this will be equal to 28.888 cubic centimeter, or this can be written as 28.9 cubic centimeter. So the change in the volume is equal to 28.9 cubic centimeter, so our correct option is A. So the most important thing which we have to remember is that delta V upon V is equal to 3 times the coefficient of linear expansion multiplied by delta T. So this is the formula which we have used in order to solve this question. So thank you very much for joining this session. In the next session, I will be taking up the another topic of the specific heat capacity. So till then, have a nice day. Bye.